Okay, in class yesterday, we started learning about loans, and we began with this tweet by a woman named Sarah Kelly, who says that she borrowed $38,876 from a private lender. The private lender is important because they're really expensive. Since graduating, I've paid that lender $31,501. So a lot of you guessed when the question was, how much does she still owe them? You were like, well, $38,876, and we take away $31,501. She should owe $7,375, right? Because she's paid back most of her loan. But then the reveal was that she still owes them $47,000. And you all were like, what? So the answer for why this happened is, quite frankly, interest. And that means, like, what interest is talking about is that banks don't just give you money for free. They give you money because they know you're going to have to pay them more money back. And you can end up in a really bad situation like this lady. So let's look at actually what a loan might look like. So here's an example loan. We're going to say that you're going to borrow $12,000 for college. The loan that you get is from a private lender and has an interest rate of 5%. In the first, this is really important, 5% really means 5 per cent, and per is really like division, and cent is really like 100. So if you want to get the decimal for this, percent, you do 5 per cent. And if you divide that on a calculator, you're going to get 5/100. So this is the actual number that we're going to work with, 0.05. And then we're going to use that formula that I introduced yesterday, which is that the total amount of money is going to be equal to the principal, which is your $12,000, times 1 plus that 0.05 to the x. And in this case, T means the total amount of money that you owe. P is the amount that you borrow to begin with, so that's going to be our $12,000. The 0.05 is the percent interest rate as a decimal, so 5% is 0.05. And then X is going to be the number of years. This is actually going to get a little bit more complicated when we meet on Thursday or Friday, but for right now, we're just going to leave it like that. So this is just an example similar to what we did yesterday. So let's figure out how much this person is going to owe. Okay, so let's fill in the things that we know. We know that at year 0, this person is going to owe $12,000. So we're going to put 12,000 here. And then let's figure out how much they're going to owe after 1 year. Well, really, what we need to do is we need to say, take that 12,000, and if we just multiplied by 1, then we would just get 12,000. So that's like nothing has changed, everything's the same. But what we want to multiply is 1 plus that 5%, and it's totally okay for you to rewrite this as 12,000 times 1.05. And that should give us exactly what we need for the next year, which if you plug this into a calculator, you will end up getting that this is $12,600. $12,600 if they pay nothing. So that's only if they don't pay any money. Now, if we wanted to, this is now how much money they owe. And to get the next year, we just need to do the exact same thing. So we could now take that $12,600 and multiply that by 105%. That's like this extra 5%. Absolutely, keep going. You can keep doing it like this. You can get $13,230. That's a 0. So $13,230. But the other thing that you could have done, instead of making this a recursive sequence where we have to get this number, and then to get this number, we need this number, to get this number, we need this number, to get this number, I can just jump straight down to 5 if I want by using this like little exponent. So right here, this P is my 12,000. The 1 is the same. That's just keeping my regular amount. The 0.05 is the same. And then this one, this X, is going to be the years. So another way that you could have gotten that exact same 13,200 is if you took 12,000 and multiplied by 1.05, but in this case, you raise it to the second power. that will get you that exact same $13,230. So if I want to get these three, here's how I can do it. I can just take 12,000, multiply by 1.05, and raise that to the third power. That gets me 13,891.5, so that's like 50 cents. So now I owe 13,891.50. If I do the same thing, but I raise it to the fourth power, then I get 14,586.08, and that's a little bit rounded, but good enough for us. If I do it to the fifth power, I get 15,315.38. What I want you to pay attention to is that this is growing really fast. So in fact, if we added a whole extra column here where we just said, like, how much did we add? This first year, from here to here, we added $600. From here to here, we added $630. From here to here, we added, from year 2 to year 3, we added $661.50. From year 3 to year 4, we added $694. From year 4 to year 5, we added $729. So look at this. In just 4 or 5 years, you've gone from owing an additional $600 to every year owing an additional $729. And that is how we end up with the situation like the lady with the tweet did, where she had so much more money that she owed. On a graph, this is what this looks like. Okay, so this is what it looks like on a graph. Here we've got our function where it's 12,000 times 1 and 5%, so 105% per years. Here you can see the table, and look how quickly this is going up, right? Twice the amount of money would be $24,000, which would be round about there. Notice it is only taking us 14 years to double the amount of money that this person owes. And keep in mind, this means that they're not paying any money off. So the idea is that they're just letting this grow and grow and grow and grow. And every year it's adding more and more and more that it did already. So what we're going to start looking at, and you guys are going to have a short project on, but like working together and collaborating and stuff, on Thursday or Friday, we're going to look at a loan where what happens, how does this change if you do start paying it off? So finish watching this, go answer the question, and that is all I have for you today.